Hi, welcome to the Chico Math Lab differential equation problem solving session. So here's the problem we are going to solve today. So y minus 1 over x dx plus dy over the y equal to 0. Then with the initial condition, y to the square root of 2 equal to the square root of 2. Okay, let's take a look at this problem here. So when first time when I tried to do this problem, I did try several, couple of different methods here. All right. So the first method I tried is try to use the exact differential equation, and it turns out it's not working. Then the second method I tried is try to do the substitution. I try to do the u equal to the y of x, and it's not very successful. So I was kind of a little struggle with that. Then finally I look at the equation, I rearrange something, then I saw the where I can start. Okay, so now let me show you what I did here. So first things here, I times the y both sides here. So I have y minus 1 over x dx plus dy equal to 0. Then as always, I like to put the dx under, so this is y minus 1 over x plus dy dx equal to 0. Okay, and then the next step, I FOIL this. All right, so I will get a y squared minus y over x plus dy dx. Okay, so here, this is where kind of, let me spot the opportunity to solve it. So I put this one as dy dx. Then here, the y over x, I put as 1 over x y. Then the y squared, I move to here is negative y squared. So this is what I say, oh, wow, this is the Bernoulli equations, right? So we know the Bernoulli, so let me write here, dy dx is plus the pxy equal to the qx y to the nth power. Then I said, well, I met, this one here is the Bernoulli distribution. So now I know how to do it, right? Because we have several video about it. So this is my what? This is my px here, right? And this is my n, okay? So my n's here is equal to 2. Okay, so that's the process. So the process number 1 is here. I'll assign the new variable v is equal to y, 1 minus n. So this is y, the 1 minus 2. So this is y, the negative 1. So I have v equal to 1 over y. I'm going to mark this in a different color because I'm going to use this later. Now the next things here, what I need to do is to take the derivatives here, right? So now I will say the dv, so the dv dx, all right, is going to be equal to negative y, negative 2 dy dx, right? So this will be negative. Okay, so this will be equal to the negative 1 over y squared dy dx. So step number 2, I need to change the dy dx to be a function of dv. So this is what, okay, so we have a negative 1 over y squared dy dx equal to the dv dx. So what I do here, I times the negative y square. So that means here, okay, so I can multiply the negative y square. Here is a negative y square. I multiply the negative y square, both right hand side and the left hand side. So this will give me the dy dx is equal to what? Negative y square dv dx here. All right. So now, see here, the while ago we said this one's here. This is my Bernoulli's, right? So dy dx is here, right? So now I need to replace the dy dx with what we just find. So this step number 3. So we're going to replace to the yellow highlight. So dy dx. So this is negative y square dv dx minus 1 over x, y equal to negative y squared. All right, so the next step here I want to do is I want to single out dv dx. So the step number 4, so here this is y squared dv dx minus 1 over x y squared equal to negative y squared. So what I need to do, I need to times negative 1 the y square times negative 1 the y square, both right hand side and the left hand sides, right? Okay, so that's good. So first term, I have the dv dx. Okay, so this one's here is negative. Oh, here, I need to be careful here. I don't have y square here. All right, so here, then this is y, so negative and negative is a positive, right? So plus 1 over x, then I have a 1 over y here. All right, then here is going to give me the positive 1. So remember I highlighted in this pink 1 over y is equal to v. So finally we have this one, dv dx plus 1 over x, the v equal to 1. All right, I'm going to highlight this one because later I need to substitute back to this one again, so I know which equations here. All right, so this is the equation. All right, so now the next steps here. After we do that, so we all know what is the next step. I need to find the integration factor. So this is, we're going to find the integration factor. So we said du dx, right, is equal to 1 over x. So this is the new thing. So we need a new px, right? So we said du dx is equal to 1 over x times u. Then we want to solving for u, right? Solve for u. Then I do the variable separation. I put all the u in one side. So it's du over u is equal to the 1 over x dx here. So now I have ln u equal to the ln x. So I can conclude that u equal to x. All right, so now remember, after that, I need to multiply this u the equal to x all the way to my greens, right? Okay, so now I will say that this is x times dv dx plus I times x, 1 over x disappears equal to v, and then this is equal to x here. Okay, so now here, remember after we did, then these terms here, really, because this will become a product rule for a function. So we still remember this one will be to the d to the dx product rule of what? XVs, right? So you take the derivative of XV. So like here, the product rule holding X, dV dx, holding V dx, right? Equal to X. Now the next thing here is integrate both sides, right? Because your left-hand side is the product derivative of a product, right? So my left-hand side will be xv is equal to what? X squared over 2 plus c, that's right? Xv plus c. Now let's go back. What is my v here? V is 1 over y, right? Okay, so now I can say v is 1 over y. So I have x over y equal to x squared over 2 plus c. That's right. Okay, so x squared plus 2 plus c. Now, so I can divide by x both sides. So in here, divided by x both sides. So this is 1 over y. So this would be x over 2 plus c over x, right? So what I did was like basically times 1 over x times 1 over x both sides. So I got 1 over y equal to the x over 2 plus the c over x. Now, let's take a look, go back, what is my initial condition? My initial condition, square root of the 2 equal to 2. All right. So now number 9, I need to put the initial condition is the y, the square root of the 2 equal to the square root of the 2. So 1 over y, so this is 1 over square root of the 2 is equal to, then the x over 2, so it's square root of the 2 over 2 plus c. All right, so plus the c, the square root of 2. All right, okay. So now let's try to solving for c's here. So in order to solving for c, so I will times the square root of the 2 both sides here. So this will be 1 equal to square root of the 2 over 2 times the square root of the 2. This will be 1 plus c here. All right. Right. So 1 plus c. Right. So now I can solving the value of c here. Okay. All right. So here we say the c equal to 0. All right. So that's why we find. So the final solutions here will be 1 over y is equal to x over 2 plus 0 over x, right? So this turns 0. So that's why my final answer, y is equal to 2 over x. Okay, that's it. So this problem is very interesting. And so, like I said, I tried the exact differential equation. Then I used the substitution. Seems did not get anywhere. And then finally, I used this Bernoulli equation and I got to solve it. If anyone have a different way to solve it, please let me know. Okay, so I'm interested to see that. All right, so it is nice to work with you again. Hope this helped. Okay, guess I will talk to you next time. Have a good day. Okay, bye-bye.